Hello guys, in this video we will be discussing in how many ways we can describe a module. Now module is a basic building block of design in the Verilog. That means if we have any design, we will be splitting the design into modules, and by splitting the design into modules we will be making our task very simpler. So now module is very important in the Verilog. Now it is a basic building block. Now let's see about the module. Now, the internals of each module can be defined at 4 levels of abstraction depending on the need of design. Now, this word is very important. Abstraction. Abstraction means you're just interested with the functionality. How that functionality comes is not important. So, for example, a 4:1 mux. If you take the example of 4:1 mux, what is its role? It is the data selector. Based upon the select line, it will select one of the inputs. Now how can you arrive that? In many ways, like you can just describe algorithmically the functionality, or you can create a gate level description for that. So it is what the abstraction means. You're just interested with the functionality. There are various levels of abstraction: higher level of abstraction, lower level of abstraction. Now the module behaves identically with the external environment irrespective of the level of abstraction at which the module is described. That means in whichever level of abstraction you describe, the module is the same. You're describing the same functionality, so it works with this, or it is the same, it behaves the same in whichever level of abstraction you describe. Now these are the level of abstractions: behavioral or algorithmic level. This is similar to the C programming. Data flow, you just need to know how the data flows through the internal registers and how the data is processed. Gate level of structural level. Here we will be working with the modules and the gates. In the gate level of description we will see. And the switch level. Now this switch level, the Verilog provides the switch level of description as well, where we can create a module in terms of switches and storage nodes, etc. Let's see the behavioral. Behavioral. This is the highest level of abstraction provided by the Verilog. A module can be implemented in terms of desired design algorithm without concern for the hardware implementation details. Designing at this level is very easy and similar to C programming level. Now means we can describe a 4:1 mux in terms of an algorithm, how it works, not how what are the internal gates and those all. We can just describe the algorithm like this. Now this is the behavioral description of a 4:1 mux. You can see there is a case based on the expression. One of the key value pair is selected. That means the output gets one of the input based on this select. So now this is very similar to the C. And next is the data flow. Here in data flow, we're just concerned with how the data flows through the module. At this level, the module is designed by specifying the data flow. The designer is aware of how the data flows between the hardware register and how the data is processed in the design. Now this is the data flow description of the 4:1 mux. As you can see, this is very small than the behavioral description. In the last video I have discussed about the assign statement. You can watch my last video, it is available. So you're just concerned with how the data flows through the internal registers. That's it. This next is the gate or the structural level. This module is here. The module is implemented in terms of logic gate and interconnection between the logic gates. Design at this level is similar to describing the design in terms of a gate level diagram. Here you are more into the hardware. You are more into the hardware. That means what hardware will give the functionality. Now this is the gate level description of the same 4:1 mux. Now here the not and or, these are the gates. By using these gates and by these variables, you are describing a 4:1 mux. Now here you are more concerned with the gate or the hardware implementation in the gate level or structural level, but you get the same functionality. The switch level here, this is the lowest level of abstraction provided by the Verilog. A module can be implemented in terms of switches in the sense transistors, storage nodes, and interconnection between them. Okay, we have completed. Before I end, Verilog allows the designer to mix and design a module in any level of abstraction. That means in any level you can mix and describe. And also in the digital design community, the term register transfer level is frequently used for Verilog description that uses a combination of behavioral and data flow. If you mix the behavioral and data flow style of description, then you will get the register transfer level. Now that's it. Thank you for watching.